Hello there and welcome to Lower 6th Further Maths A Level. This is the core part of the syllabus. We're on specimen paper, question 8. Figure 1 shows a sketch for y equals x to the power of 2/3. The region is bounded by the x coordinate of 8 and this curve here. The region R2 is bounded by the y-axis and the curve as well. It's rotated 360 degrees through the x-axis. The solid V2 is formed by rotating R2 around the y-axis, right? Okay, so it's not just a case of taking that cylinder and taking it away. This one here is going to rotate that way round, and this one here is going to rotate that way round. Show that the exact volume of the solid V1 is equal to this. Okay, so let's pull out the formula to start with. We need pi times the integral, and it's going to be between 8 and 0 of y squared dx. So this is going to equal pi times the integral from 8 to 0 of x to the power of 2 over 3 squared. So that'll be x to the power of 4 over 3 dx. Okay, let's start the integration process now. So it's going to be increase the power by 1, so it's going to be x to the power 7 over 3, and divide by the new power, so times by 7 over 3, in between the boundary of 8 and 0. And then all you need to do from there is grab your calculator out, plug 8 into there, and you get 384 pi over 7, just like you do in there. Okay, nice and easy. 4 marks to get us started there. Part B, the two solids V1 and V2 are placed in an empty container. A solid is selected at random and then replaced in the container. This is repeated 10 times. Given that the probability of selecting each type of container is proportional to its volume, find, to 4 decimal places, the probability that V2 is selected 8 times. Okay, so selected 8 out of 10 times. This is striking me as a binomial distribution question. What we need to know here is, well, we've got 10 trials, but we need the probability that we select V2. So let's go ahead and work out what V2 is. V2, now V2, remember, was rotated this way round. So let's first work out this boundary marker here. If we've got 8, that would be a 4 up here, because 8 to the power 2/3 is 4. So the volume is going to be between 4 down to 0, or this time it's the other way around, x squared dy. So taking the formula for y equals x to the power of 2 over 3, let's cube both sides and we'll get y cubed equals x squared. We don't need to square root here because we actually want this x squared. So it's going to be y, so it's 4 to 0 of y cubed dy. Let's do the integration now. So it's going to be a quarter y to the power of 4 in between 4 down to 0. Oh, we're missing the pi. Whoops. Pi. So this is going to be, well, that will cancel out one of the 4's. So 4 to the power of 3 is 64 pi, and we're not going to take away anything because it's just a 0 there. Great. So the probability of selecting V2 is going to be 64 pi over the total volume of this, which is going to be 64 pi plus the other probability, which was 384 pi over 7, and this quite nicely simplifies to 7 over 13 when you put it into a calculator. Okay, so 7 out of 13 is the probability that we select V2 on each of the on each pick. So using the binomial probability, x is going to be binomially distributed 10 10 events and a probability of 7 over 13, a bit more than half. So the formula here for when x equals 8 is going to be 8 choose 2 lots of 7 over 13 times, to the power of 8, times, and then we need to do the opposite, the probability of failure, 6 over 13 to the power of the number of failures we need, which is 2. And bashing all of that into your calculator, and you get 0.0677 to those 4 decimal places that were required. Okay, so a bit of a surprise there, binomial distribution coming up in a further maths paper, but we need to assume that all knowledge from the AS maths can be used, and this is in AS level maths, so we can use it. Alright, 11 marks for this.